Hi everyone. Today we're going to talk about solving trig equations by graphing. Now, we've already solved trig equations using algebra and the cast rule, and we've already learned how to graph trig functions and the transformations of them. So now we're going to merge those two ideas together. The first few examples are a warm-up so that we can sort of refresh what it is that we've learned already. You should be able to do the first two questions on this page as well as the two graphing questions without any difficulty. So I'd like you to give those a shot first and then play the video and check your work to make sure that you're on the right track. Okay, so for this first example, we see sine x is equal to 1 over 5. The range that I'm working in is from 0 to 360 degrees. So I'm trying to find the angle. Using the cast rule, I draw out my cast symbol so that I can look at my diagram. And I look at my question and I know that sine is positive in quadrant 1 and quadrant 2. So I know I'm going to have an answer here in quadrant 1 and quadrant 2. So I put in an alpha, and when I do, I know that it's in the first quadrant. I use my calculator. I go second sine 1 over 5, and I get alpha is equal to 11.5 degrees. That means in the first quadrant, my answer is 11.5 degrees. And in my second quadrant, it's 180 minus 11.5, also known as 168.5 degrees. In the second example, I'm going to do something similar, so it doesn't look like what I want it to look like, so I'm going to rearrange first, and then I'm going to use the cast rule again. So for this first graph, what I'd like you to do is fill out the necessary information, and then sketch the graph on the grid below. So here I know I'm drawing a sine graph, and this sine graph has a period of 180 degrees, known as 360 divided by the 2. I have an amplitude of 3, but it's been reflected because of the negative sign, so I know that that starts going down first before it goes up. And I also know that my principal axis is y equals 1. So start with your principal axis and draw the curve. Okay, so when I drew this graph, if I want to break it down, I started by labeling the principal axis, so here you'll see it in red at y equals 1. Then I knew that a period or one cycle fit into 180 degrees. I know the sine curve starts at the principal axis, so I drew on the first 3 points. It starts at the principal axis, it ends at the principal axis, and halfway it also hits the principal axis. I know that the amplitude is 3, but it's been reflected, so halfway between the first 2 points it's going to go -3, and halfway between the second 2 points, I know it's going to go as high as 4, so it went 3 up in the amplitude. And then I need to fill in the second half from 180 to 360, but it's an identical picture to what I've just drawn, so the same points repeat itself. Try the next example. So for this example here, the amplitude is half. The period is 360 divided by 4, which is 90, so that means one co-cycle fits in 90 degrees. And the principal axis here is y equals 0. Again, start from the principal axis and fill in the information that you need. I'm going to recommend that you maybe double the scale so that your diagram is a little bit easier to read. So for this cos graph, I start with my principal axis here in red, y equals 0. I know that the cos graph starts normally at 1, but because the amplitude is a half, it starts at a half. 90 degrees later, because that's one cycle, it ends at a half. Halfway between that, it's -1/2, and if I fill in the holes there, it'll be 0 and 0. And then when you have that first cycle, you're able to fill in the other 3 that fit between 90 degrees and 360 degrees. Okay, so we're now at the point where we're going to merge those two pieces of information together. We're going to use our knowledge of graphing trig functions and solving trig functions using the cast rule and sort of put that idea together. So the first part says graph the function f of x is equal to 2 sine x plus 1. So everybody take a moment, draw that function. If you need to, in the space up here in the blank space at the right top corner, please write down the amplitude and the period and the principal axis if that helps you to draw your diagram. Okay, so here in blue you'll see my function, my f of x function. I had a principal axis of 1, an amplitude of 2, and this is the graph that I received. The next part asks you to graph the line y equals 3 on the sketch. So I'm going to do that here in red. So here is my line y equals 3. And you'll notice right away it says then find where f of x, or the function, is equal to 3. So right here you'll notice that the function equals 3 right here at 90 degrees. So using my ability to graph a function and then another function, I can find where those two functions intersect. Or another way of putting it is I can solve the trig function. So what I've just done, if I'm looking at it really carefully, I've just done this. I've done 2 sine x plus 1 equals 3. And I've solved that. And in my solving that, I got 90 degrees. Part C asks me to find where the f of x, so the function in blue, intersects 0 or hits the axis. So right here, that's here at this point here and here. So it asks me how many solutions there are. So there are 2 solutions. And then it says find the solutions. Now because my graph is accurate, I can read off the graph and tell you that my answers are going to be 210 degrees and 330 degrees. Let's say your graph wasn't an awesome graph and you need to solve it algebraically and using the cast rule. Well, let's try that now. Basically what we're doing is we're saying, sorry about that, 2 sine x plus 1 is equal to 0. That means sine x is equal to negative a half. And you say to yourself, where is sine negative? Or sine is negative here in quadrant 3 and here in quadrant 4. So I know I'm going to have an answer in 3 and an answer in 4. I'm going to plug in my alpha and I'm going to go to my calculator and go second sine a half, and out will come alpha is 30 degrees. So that means that in the third quadrant it's 180 plus 30 degrees, which is my awesome 210. And then in the fourth quadrant, it's 360 minus 30 degrees, which is 330. So you'll notice that these answers and these answers here are the same. So that's why graphing and solving works together. Okay, this next question says, consider the following function, g of x is equal to minus 6 tan x cos squared x, and we're only looking at it from minus 180 to 180. Well, I'm not expecting that you should be able to graph this just by simply knowing what it's going to look like. But I am expecting you to be able to use your graphing calculator and make a sketch of it. So if you're inputting it into your calculator, make sure that you enter it in like this. So you go to the y equals button and you say negative 6 tan x, and then put in a bracket and go cos x, close the bracket, and square that. That's definitely a better way of entering in the equation, and you'll be able to get out a great graph. So pick up your graphing calculator, punch this into the y equals button, make sure your graph is in zoom trig. You'll want to go to the window and make sure that it goes from, let's say, negative 180 to 180. And you probably want to go up by increments of 45. That might really help you get a good diagram. When you do that, draw your diagram on the grid below. So when you graph it, you should get something like this. Maybe a little less shaky than mine is, but pretty much the same idea. Now, a common question is to then say, looking at your graph, can you tell me another way to express the function? In particular, this one here is saying, can you tell me what it would be as if it was a sine graph, and find the values of A and B? Well, if this is a sine graph, notice one cycle fits in 180 degrees. All right, that means we know that B is 2. So we know that g of x right now is something sine 2x. And if we're looking at it, we know that the amplitude is 3, but it starts to go down first, so A is negative 3. So in order to figure out what my values of A and B are, I need to go back in my diagram and look for the amplitude, the period, and the principal axis. Luckily here, the principal axis is 0, so I don't have anything else attached to it. Next, it says to take your diagram and figure out where g of x, so the function in blue, is equal to 2. So if I want to draw that on, that's great. I'm drawing that on here at y equals 2. But you'll notice that there are 4 intersection points here, 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 and here. I'm not expecting you to give me an exact answer just by looking at your graph. What I am expecting is that you punch this, y equals 2, into your y2 button and use second trace intersect to find where those points intersect. And when I use my calculator, I get negative 69 degrees, negative 20.9 degrees, or negative 21. I get 111 and 159 degrees. And that looks pretty good according to my graph. So we're on the right track here. The next part, it says on the same domain, so from negative 180 to 180, graph now cos 2x. So use a different color here and graph cos 2x. Okay, so you'll notice I drew my cos 2x graph here in green. It asks you to figure out how many solutions there are, or when my blue graph and my green graph intersect, but only from 0 to 180. Notice that that's bolded. So that means that there are only 2 solutions from 0 to 180. So 0 to 180 is from here to here. There are 2 solutions. One's right here and one's right here. Now it asks me to find them. So again, I go to my calculator, and this time instead of in the y2 button having 2, I'm going to put cos 2x in the y2 button. Again, I'm going to let it graph, and I'm going to find those 2 intersection points. And those 2 intersection points are here at 81 degrees and here at 171 degrees. So not too bad. They look exactly like they should. They're in that vicinity in their region. And again, please remember, I would not ask you to graph and solve just by looking at the graph with something this difficult. I would expect that you would put the 2 functions into your calculator, make sure they graph properly, that you have the correct window, and then use the second trace intersect option to find those intersection points. All right, so here's my last example for the day. It says I want to solve the equation where this here in red is equal to this here in blue. So I recommend that you graph the 2 functions, preferably in different colors. Okay, the blue one you should be able to do knowing what you know about transforming graphs. The red one you should be able to do using your calculator. And then when you're done, find where they intersect, again on your calculator. So take an opportunity, draw out that, and check back to make sure that your work is correct. So I chose to draw the blue graph first. Again, I know how to draw this one, understanding transformations. So I know that my period is 180 degrees and my amplitude is 3. It's been reflected as well, and it's a cos graph, and the principal axis is y equals 0. So this one here should have been easy for you to draw. Now, using your calculator, please make sure that you can draw now the function in red. So using my calculator, this is what my red graph looks like. And then lastly, it asks you to solve. So that means find the points of intersection. So if you've drawn this in your calculator and you've put the red graph into y1 and you've put the blue graph into y2 and you've solved, you should get one answer here at 45 degrees, one answer here at 153 degrees, one answer here at 225 degrees, and your final answer here at 333 degrees. So, the point of today's lesson was to be able to solve and solve by graphing. So I'm going to look to make sure that you understand how to transform a graph that you already know, such as a sine or a cos, how to use your calculator to draw a curve that you don't know, so an unfamiliar trig curve. That means just use your calculator and get the key points, and then to solve, which means set them equal to one another. So put one function into y1 and the other into y2 and find where they intersect. take an opportunity to try the homework. It's a really good test of whether or not you can graph and understand solving. And I hope to see you again soon. Take care.